Today we're going to be working on Leetcode question number 375, guess number higher or lower, part 2. We are playing a guessing game here. The game will work as follows. You're going to be picking up a number from 1 to n. You guess a number and then you win the game if you get the right number. But if I tell you whether the number I picked is higher or lower, you will continue guessing. But every time you tell a wrong number, you need to pay that much dollars. So this explains here the output is 16 because so the number was picked up between 1 to 10. The winning strategy is as follows. So you guess a number 7, and if it is not that number, right, uh, like we're gonna be told that whether it's higher or lower, but we need to pay $7 if it is not that one. So 7 and 9 is a combination which can be told, uh, which is gonna uh, which is gonna which is gonna tell us that we have to pay 16 if we make two mistakes, right? And then we're gonna end up paying $16. So with $16 we can guarantee that we can get to the right solution. The way we're gonna be doing it is using recursion and memoization or dynamic programming. So for that one we're gonna have a table. Okay, we're gonna have a table which is basically the size of that is gonna be n plus 1 and n plus 1. And in the end, once we are gonna be using the dynamic programming for that, let's call it dp, and it's a helper function which also do the memoization uh, and keep updating our table, and we're gonna be returning 1 through n. So this is the range, and we're gonna be basically be returning uh, we need the ith row and the nth column value for that. So we're gonna have a helper function, let's call it dp, and this dp is gonna take the table, and it's gonna have uh, the row and the column. Okay, if the row is greater than equal to column, then we just want to return, we don't want to process that. Okay, and if it is if it we have already processed and uh, it is not 0, we're just gonna return whatever the value is. So if the t row column is not equal to 0, that means we have already processed it, so you can return it. Return tr and then c. Okay, then we are gonna have our result equal to, initially it's a maximum value, jar dot max underscore value. Okay, and then we're gonna go through it by saying that our I uh, sorry for int I, it's gonna start with our row, and the I is gonna go through all up to the column, and then I plus plus, right? And then we're gonna have a temp result, which is basically gonna be this I plus uh, the max between the dp, we're gonna recursively call that the table, and the row is gonna stay the same, but we're gonna say that our column is gonna change to I minus 1, and the other one is the dp, the same table, but this time the row is gonna become the I plus 1, and then the column is gonna stay the same. So between that and uh, whatever is the minimum value between whatever the result was and the temp. So we're gonna do that. We're gonna update our row call like the table with this result, and we're gonna return the result. So the reason we are doing it is because we don't know whether we need to go to the right or left in order to come up with a optimized cost. That's why we need to check both ways. Once we are setting the column to I minus 1, and once we are setting the row to I plus 1. Yep, and it works.